Okay, here we have an application problem dealing with decimals, and this is kind of talking about decimals being larger and smaller than other decimals, so we're going to have to really think our way through this one. This says the average length of a newborn baby is 20.8 inches. Charlene's baby is 20.08 inches. Is her baby longer or shorter than the average? And then by how much? Okay, well, let's just kind of think our way through this, and we're going to talk more about larger and smaller decimals next. But they said that the average was 20.8. Now think about how we would read that properly. That would be read as 20 and 8 tenths. Now Charlene's baby said was 20.08. So if we read that properly, that would be 20 and 8 hundredths. Well, if you think about 8 tenths and 8 hundredths, 8 tenths is a lot larger of a number. If you were to think about having like a rectangle that was broken up, well, that didn't make a very nice rectangle, did it? If we were to break this rectangle up into 10 equal parts, so that'd be 1, 2, 3, 4, 5, 6, 7. Oh, I'm running out of parts there. If I were to shade in 8 of those, that would be quite a bit of that rectangle. Well, if I were to do the exact same thing, breaking it up into 100 parts, however many that would be, and then I were to color in 8 of them, that's a whole lot less visually than this picture. So 0.08 or 8 hundredths is much smaller than 8 tenths. That tells us then that her baby is shorter than what the average baby was. Then it says by how much. Well, in order to figure out by how much, we could just do the subtraction. So if average is 20.8 and hers is 20.08, we can literally do that subtraction there. Now I'm going to put a 0 placeholder in here so that we can see that subtraction. I can't take 8 from 0, so I'm going to have to borrow. So now 10 minus 8 would be 2. 7 minus 0 would be 7. Line up that decimal. 20 minus 20 is nothing. So it looks like her baby is shorter by 0.72 inch.